Okay, now let's look at exercise 2G. These are all the various functions. Okay, some of them has an inverse, some of them don't have an inverse. Okay, how do you know whether they are? How do they know whether this function have an inverse? Very simple. What you do is you use the horizontal line to check. Okay. For example, now if I draw a horizontal line, is there any horizontal line that intersect at 2 points? No. So this is a function. Yes. Okay. So this is a one-to-one function. Yes. One-to-one. This one, yes. What about this? You draw them. So if I draw a horizontal line to intersect at 2 points, here and here, therefore it doesn't have an inverse function. Okay, this one is no. This no. Okay, if you know you don't have an inverse function, I mean it's not one-to-one, then it doesn't have an inverse function. If it doesn't have an inverse function, then the domain and the range of the function doesn't apply onto the inverse function, since the inverse function doesn't exist for this case. Okay, get it? Now we're going to look at some example and work it out. Like for example, B, 1B, since this inverse is a one-to-one function, it has an inverse. Okay, now let's look at the domain of the function first. Okay, the domain of the function will be from x, this point onward, x equal to 0, all the way until minus very large value, because this is continue all the way. So in this case, x shall be this x shall be less than or equal to 0. That is the domain. Okay. Let's repeat here, x from here onwards will be negative value, but very big negative value. So x is equal or less than 0. The range, which is y, will be minimum is 4. That's how low the graph can go, 4. Okay. So y has to be equal to 4 or more than 4. That's it. That y has to be equal to 4 or more than 4. From here onwards, y is more than 4. Okay. Now, the inverse function. How do you draw the inverse function? Let's draw this line, which actually y equal to x. Now, if I draw the inverse, this one reflect over here will be 4. Okay. If you reflect over here, a straight line, we will show curve in this manner. Okay. There's some mistake here. We shouldn't have show any sign of curving up at all. It's always going down. What is the curve? This way. Okay. Okay, this one reflect over here, it look like that. Now let's go back to the inverse function. Since it has an inverse function, okay, it's a one-to-one function, has inverse function, therefore we can swap. So the domain is actually taking the range, okay. Domain y if more than or equal to 4 become x more than or equal to 4, okay, and then the range is taking the domain. So y is less than or equal to 0. Okay. Now let's come back to the graph that we have sketched. Okay, the inverse function. Let's look at it, see whether it makes sense. Now domain is 4 or more. Okay, you can see from here, this point is 4. So the x value is all the way. Okay, all the way. So x has to be more than 4. Now what about y? See, this graph will go below the x-axis. That means the graph will only exist when the y is 0 or less than 0. So y is equal or less than 0. So this is correct. Okay. Whatever you get from here is it reflects onto the inverse function that we have sketched. Okay. Now, so this one don't have is not one-to-one. Therefore, you don't have an inverse function. Okay. Now, let's look at this case here. This case, g, 1g, okay, function. Look at the function here. What is the domain? First of all, let's check whether it has an inverse function. Let's draw horizontal line. If you draw horizontal line, you discover that there is only one point of intersection for each horizontal line. Therefore, it is a one-to-one function. Therefore, it has the inverse function. So if it has the inverse function, then we will proceed with whatever the question wants. So the domain here is x. X is from here onward, and x will continue. Okay, will continue. So x has to be equal at this point equal to 0 or more than 0. The range, I mean the y value, y after y, whatever the part of the graph will always go below 3. So y will be either equal or less than 3. Okay. Now let's sketch the okay. Now this is equal to y equal to x. Okay. Now, if you reflect this is how it looks like. Okay. You reflect along these 3 will come over here. Okay. 3 here. This point we do not know what's the intersection, but this point, when you reflect this point, when you reflect with this axis, this point will come over here. Okay, the x-intercept come over. So the graph will look like that. Okay. Oh, sorry. It will look like